Hello students, welcome back. I hope that you have understood the first part of matrices, that is the initial definitions and the types of matrices and some special types of matrices. Today in this part, we will be discussing about what are the operations that are related to matrices. So first of all, we need to know that what types of operation does matrix have. So first of all, it has addition, scalar multiplication and multiplication. So these are the three types of operation that we're going to discuss in this part. So let's get started. The first one is addition. Now, two matrices are added by adding the corresponding entries. Now, what does that mean? Now, adding corresponding entries means that if there are two matrices that needs to be added, each and every entry at its position will be added with its own position on the other matrix. Now, what does that mean? Let's take an example. Let's say we have two matrices out here. Let's say consider this matrix as matrix A, which has element 1, 3, 5, 6. Let's consider this matrix as matrix B, which has elements 2, 4, 2 and 1. In order to, if we are adding these two matrices, so as it is said that we need to add those matrices by adding the corresponding entries. That means that like we will be adding, this is the position, that is first row first column of matrix A will be added to the first row first column element of matrix B. Now first row second column element of matrix A will be added with the first row second column of second column entry of matrix B. So this is how you add two matrices. So as you can see that I have added these two matrices and the result is 1 plus 2, 3 plus 4, 5 plus 2, 6 plus 1. The end result is, the final result is 3, 7, 7 and 7. Now let's just consider another example. Okay, in previous example we have seen adding a 2 by 2 matrix. A 2 by 2 matrix means a matrix that has 2 rows and 2 columns. Now out here you can see that we have a matrix of order 3, that is 3 rows and 3 columns. Same steps, same procedure will be followed. That is, we'll add the corresponding entries of two matrices, that is 1 plus 2, 0 plus 3, 3 plus 1, then 6 plus 0, 8 plus 2, 0 plus 7, 7 plus 1, 1 plus 11 and 5 plus 7. So that is how you just write it down like this, and the final result that you get is 3, 3, 4, 6, 14, 7, 8, 12 and 12. So that is how two matrices are added. Now there is something that you need to know before adding all the matrices, and that is that two matrices are only added if they have the same dimensions. Now this is very important. When you are adding two matrices, only those two matrices will be added together if they have same dimension. That means if the order of two matrices are same, that the matrices that are added together, the order should be same. If they don't follow, if you just don't follow this condition, if this condition is not followed, so then two matrices cannot be added. Now what does that mean? Let's just understand it better with an example. We have these two matrices. Now as you can see that first matrix has element 1, 3, 5 and 6. Okay, and it is a 2 by 2 matrix, 2 rows and 2 columns. Now this second matrix, as you can see, it's a column matrix. It has 1 column and 3 rows. So it's like 3 rows, 1 columns. Now these two matrices cannot be added together. Why? Because these two matrices don't follow the same dimension. The dimension for this matrix is 2 by 2. The dimension for this matrix is 1 by 3. So these two matrices cannot be added together. See, there are certain rules and regulations that we need to follow while adding different things. For example, if you're doing matrices, we follow certain rules so that we work accordingly, so that if we know the condition that if this dimension thing does not follow here, so we don't need to proceed further. Okay, so for addition on matrices, it is necessary that two matrices that are added together should have same dimensions. Moving on to the next part, that is the scalar multiplication. Now what is scalar multiplication? That is, let's see, let C be any scalar and A be any matrix. So matrix multiplication is done by C into A. Now out here we're not talking about two matrices multiplying together. Okay, we're just considering C that can be any scalar. Okay, any scalar value means it can be any number. Okay, any number, if there is any number, any particular single number, any scalar value that needs to be multiplied by a matrix. So how we will do that? So let's just consider an example. Okay, now out here I've taken C as 4. So as I have written here, C be any scalar. So C out here is 4. And A is a matrix that has element 1, 3, 5 and 6. Okay, so if we need to multiply C and A, now out here you can see that I've multiplied 4 multiplication with this whole matrix. Now what will be the result? The result will be that this scalar will simultaneously multiply with each and every element of the matrix. Okay, that is equals to 4 multiplied by 1, 4 multiplied by 3, 4 multiplied by 5, 4 multiplied by 6. Now you can see the result out here. The result is 4. Okay, the result is 4, 12, 20 and 24. So this rule follows for any scalar. Now this scalar can be any number, right? Scalar if multiplied by a particular matrix. Now out here I've considered a 2 by 2 matrix. Okay, so the same rule follows for 3 by 3, 4 by 4 and n order of matrix. Okay, so if any scalar is given, and you need to multiply a matrix with that scalar, that only means that that particular number will be multiplied by each and every element of the matrix that is given to you for multiplication. So this was like for scalar multiplication. Now if we need to know that, in previously we say that we took a scalar 4 and we multiply it with a matrix. Now we are saying that we don't want a scalar to be multiplied a matrix. We want a matrix that is to be multiplied with the other matrix. Okay, so let's consider, let A is equals to 5, 3, 1, 2. Okay, it's a 2 by 2 matrix, and B is a matrix that has elements 2, 0, 8 and 1. Now first step is multiply first row with first column, then first row with second column. See, now when you're multiplying two matrices together, the first step that you need to follow is, we know that there are two. Now you can see that there are 2 rows and 2 columns. The dimension of the matrix is same for this case. Okay, so how we multiply these type of matrices? Okay, first of all, see, for multiplying, it's clearly written that multiply first row with first column, then first row with second column. So how it is done? Then second step is multiply second row with first column, then second row with second column. Now how it's done, let's see. The sign used when multiplication row and column is plus. So these are the steps that we are going to follow while multiplying two matrices. Okay, so this is my matrix A, my matrix B. If I'm multiplying AB, okay, now the output may vary. Okay, the output may vary when we're multiplying AB or BA. The dimensions may vary too, but that is another case we're going to work on. Okay, so first of all, it says that if you're multiplying two matrices, now out here I have taken two matrices of same order, and you're multiplying that. If A is multiplied by B, okay, so what you're going to do is 5, the first row, as it says, you need to multiply the first row with first column, then first row with second column, then first row with second row with first column, and second row with second column. Now how we do that? Okay, now first of all, first row first column, now 5, this first entry, first row first column of matrix A will be multiplied by first row first column entry of matrix B. Okay, now sign we are going to use is plus in between. Then first row second column element of matrix A will be multiplied by second row first column of matrix B. So 3 multiplied by 8. If you just go back and look at what it's written, that we need to multiply first row with first column, then first row with second column. So multiplication happened with row and column multiplication. See, right, we're going to multiply row and columns together when we are dealing with matrix multiplication. Okay, now you can see next first row second column. Now first row second column, the first row first column element of matrix A to be multiplied by first row second column element of matrix B. Then first row second column element of matrix A to be multiplied by second row second column of matrix B. So that's how it's written. 5 multiplied by 0, 3 multiplied by 1. Now same follows for row 2. Now 1 multiplied by 2 plus 2 multiplied by 8. 1 multiplied by 0, 2 multiplied by 1. So the end result is 10. See, 5 into 2 is 10, 3 into 8 is 24. So I've done all the calculations out here, and the final answer was 34, 3, 18 and 2. We are taking another example. Now we are considering a 3 by 3 matrix. Okay. Now as you can see, first of all we are multiplying those matrices that has same dimensions. Okay. So if you're going to multiply this matrix A with B, same rule follows. First row first column, first row second column for second entry, first row third column for third entry. Now second row first column for this place entry, second row second column, second row third column. So if you're multiplying A multiplied by B, now you can see out here, see, 5 multiplied by 2 plus 1 multiplied by 0 plus 8 multiplied by 1. Then 5 multiplied by 3 plus 1 multiplied by 6 plus 8 multiplied by 11. Then 5 multiplied by 1 plus 1 multiplied by 7 plus 8 multiplied by 7. Now same follows for second row and third row. Second row first column, now this is 2 multiplied by 2, 8 multiplied by 0, 0 multiplied by 1. Then 2 multiplied by 3, 8 multiplied by 6, 0 multiplied by 11. Then 2 multiplied by 1, 8 multiplied by 7, 0 multiplied by 7. Now third row first column, third row second column, third row and third column. Now you can see 5 multiplied by 2 plus 1 multiplied by 0 plus 5 multiplied by 1. Then 5 multiplied by 3 plus 6 multiplied by 1 plus 5 multiplied by 11. Then 5 multiplied by 1 plus 1 multiplied by 7 plus 5 multiplied by 7. Now this is all the working that I've done here. I've added all these matrices and finally I got the answer, which is 18, 94, 68, 4, 54, 58, 15, 97 and 47. Okay, now here's another important note when multiplying two matrices. For two matrices to be multiplied, it is important to know that they can only be multiplied if the number of column of first matrix is equal to the number of row of second matrix. See, earlier we were multiplying only those two matrices that has same dimensions. Okay, now if we wanted to multiply two matrices that don't have same dimensions, so there is an important rule that we need to follow before multiplication of two matrices, and that rule is that the column of first matrix, okay, should be equal to the row of second matrix that are being multiplied. Now let's say we take an example like here. Now these are two different matrices, okay, have two different dimensions. Matrix A has dimensions let's say 3 into 2, that is 3 rows 2 columns, whereas matrix B has dimension 1 into 4. Now these are two different matrices having different dimensions. Earlier we saw how to multiply two matrices having same dimensions or same order. Out here the condition is that there are two matrices and having completely different dimensions. Now if we need to multiply these two matrices, as according to the rule, it says that we need to check that row of, first of all we need to know that which is A is multiplying by B or B is multiplying by A. So let's say if A is multiplied by B, so these two matrices cannot be multiplied. Now why? For A multiplied by B, the dimensions are 3 into 2. For B it's 1 into 4. Now order of A is 3 into 2. Order of B is 1 into 4. So we are talking about 1 A multiplied by B. You can check for B multiplied by A as well. Okay. Order of A is 3 into 2, order of B is 1 multiplied by 2. We said earlier that for these two matrices to be multiplied, it needs to follow that column, that for the column of matrix A should be equal to the row of matrix B. Okay. Now as you can see out here, column is 2, whereas row for matrix B is 1. So these two matrices cannot be multiplied together. So let's just take another example. Let's say we have these two examples. Okay. As you can see, I have changed matrix B a bit. What I have done out here, now these two matrices has completely different dimension. Matrix A has dimension 3 by 2. Matrix B has dimension 2 by 3. Okay. So now order of A is 3 multiplied by 2, 3 by 2. Order of B is 2 by 3. Now in order for these two matrices to be multiplied, the rule that we know is that if A is multiplying by B, okay, so the column of matrix A should be equal to the row of matrix B. Now as you can see, this is the second position defines basically column, this position defines row. Now out here you can see that both are same. 3 multiplied by 2, 2 by 3, 3 by 2 matrix, 2 by 3 matrix. The column of first matrix is equal to the row of second matrix. So if you are multiplying AB, okay, AB, so same rule follows. Row multiplied by column, row multiplied by column, row multiplied by column. The result will be a 3 by 3 matrix. A 3, you can see what will be the, you can also check what will be the result. You just write it down the order out here like this. Okay. So if these two places are equal, multiplication is possible when dimensions of two matrices are different. And the result will be this 3 by 3 matrix, a 3 by 3 matrix. Now how come? First row, first column, first row, second column, first row, third column. 3 multiplied by 2 plus 1 multiplied by 1. 3 multiplied by 6 plus 1 multiplied by 0. 3 multiplied by 1 plus 1 multiplied by 5. Then 4 multiplied by 2. Now we are talking about second row. 4 multiplied by 2, 6 multiplied by 1. 4 multiplied by 6, 6 multiplied by 0. 4 multiplied by 1 plus 6 multiplied by 5. You can see out here. Then third row, first column, 3 multiplied by 2, 0 plus 0 multiplied by 1. Second entry, 3 multiplied by 6 plus 0 multiplied by 0. Then last entry, 3 multiplied by 1 plus 0 multiplied by 5. Okay, so this is the final result and this is your final answer. So when you're multiplying two matrices together, you all need to know that two matrices will only be multiplied if they have different dimensions when the number of columns of first matrix is equal to the number of rows of second matrix. Now out here, what happened? Okay, what happened if I multiply, out here I multiplied A into B. What if I multiply B into A? Now I need to know B into A means that if this position is first 3, now the column of B should be equal to the row of, now column of B should be equal to the number of rows of matrix. If you are doing the opposite, that is out here we multiplied A multiplied by B, if you are doing for B multiplied by A, so we're going to follow the same thing. Now for this condition we can see, yes, the number of column is 3 for order for matrix B. The order for matrix B is 2 by 3, that means the column is 3. For row of A is also 3, so 3 by 3, yes, these matrices will be multiplied, but the result will be, the dimensions will be changed. Okay, now the final answer that you will get will be a 2 by 2 matrix, and I hope that you will do it, you practice this, and let me know if you have any queries about it. So that's all for this part. I hope that you have understood the operations that are related to matrices. We'll see you soon in the next part. Take care.